Number of solutions for a linear system. Here's a practice test question for you. Analyze the given set of equations. Predict the number of solutions for each linear system, right? So we are given 6 linear systems here. I'd like you to pause the video, analyze and write down the number of solutions for each. Let's begin. So the first one is y equals to 2x minus 3 and y equals to 4x minus 6. Now in this, two slopes are 2 and 4, right? So they are totally different slopes, and therefore how many solutions do you expect for this one? Well, since m1 is not equal to m2, we expect only one solution, right? So the number of solutions is 1. Now in this particular case, 2x minus 3y equals to 1, 4x minus 6y equals to 4. We don't really have to convert to slope and intercept form when equations are given in this form. You can see if I multiply the first equation by 2, what happens? I get 2 times 2 is 4, 2 times 3 is 6, but 1 is not multiplied by 2. You see, this is different. Correct? So it is not the same equation. If it is not the same equation, then it is a parallel equation. Here, since these two are multiplied, not the constant, we have m1 equals to m2, but b1 is not equal to b2, so the lines are parallel, right? So lines are parallel, and how many solutions do you expect? None, right? So let me write down no solution, right? So we expect none. Reason is that the coefficients are multiplied, these two numbers are multiplied, but not this one. That is why, correct? See, x plus 2y equals to 1 and 2x plus 4y minus 2 equals to 0. So what you should consider is that you can take 2 on this side. So we have to think like this, that we have 2 here, okay, plus 2. Now, if I multiply this equation by 2, what happens? If I multiply this by 2, then what happens, right? So I'm just showing you, it becomes 2x plus 4y equals to 2, which is same, right? When I bring this 2 on the right side, so they are same equations, right? So this is coincident line. And if they are coincident lines, then how many solutions do you expect? Infinite. Okay, so that's absolute, they're exactly same equations, correct? Now D is y equals to x and x equals to 1. Here, what is the slope? Here the slope m1 is equal to 1, coefficient of x, and this is a vertical line. So what is the slope of m2? Undefined, right? So these slopes are not equal, they are perpendicular lines, and we have number of solutions. These are actually not perpendicular, but well, let me now sketch it. Okay, let me sketch it now. So let us say x equals to 1 is this line, and y equals to x is a line which is going like this. It has one solution, right? So since the lines are with different slopes, number of solution is 1. So that is the number of solution for this line. Now let's look into the next one. Y equals to 2 over 3x minus 3, and then we have 2x minus 3y minus 9. It's a good idea in this case to write it in slope and intercept form. Okay, so if I write this in slope and intercept form, what do I get? I will take 3y to the other side, and then we'll divide by 3. So we get 2 over 3 and minus 3, correct? It is exactly the same equation, x, correct? Now the slope is same, so what we have seen is they are same lines. Y-intercept is also same, so b1 equals to b2, and we also have m1 equals to m2, and so we again have infinite solutions, right? So we have infinite solutions, right? The last one, I'm leaving that for you to figure out. In this equation, 2x minus y equals to 5 and to y minus 4x equals to minus 10. How many solutions will that have? You can adopt any method which we have learned. You can write both in terms of slope and intercept, or you can just multiply by a factor and see whether coefficients are multiplied or coefficients and the constant is also multiplied. If only coefficients are multiplied, then the lines are parallel, and if coefficients and the constant is multiplied, the lines will be coincident, same lines, and they will have infinite solutions. If they are parallel, of course, no solution, correct? I hope that helps to review what we have learned about solutions for linear systems. I'm Anil Kumar. You can subscribe to my videos and learn a lot about similar topics. Thank you and all the best.